Hi guys, welcome to Learning Electronics Repair, and I have a box full of PCBs on my desk today. These were sent to me by PCBWay.com, who are sponsoring this video. PCBWay manufacture all sorts of PCBs. You can see, for example, for small PCBs, $5 for 10 pieces of single or double-sided, build time 24 hours. From $29 with free shipping, 1 to 20 pieces. This is for assembled boards. Assembly, of course, depending on what components you want fitted. And they also have the shared project section, where you can look for all sorts of user submitted projects and maybe find something you're interested in buying. I've built quite a few of these in the past, and I've submitted some. And by the way, if you submit your own projects, then you get 10% commission on any sales. There are also links to some useful tutorials about designing PCBs and other topics that may interest you. So I'm sure you are asking, Richard, what's in the box? Well, in here I have the PCBs that were submitted for the Build a Signal Injector pen in a pen competition. So I have, I think, 7 different versions here that people submitted. So let's have a look at those. Let's see what components we have. I ordered quite a lot of stuff to build these, but I probably need some parts I missed. I will just point out, by the way, that PCBWay.com sent me these PCBs free of charge as part of the sponsorship deal I have with them, but I'm paying myself for all the components, and I will be the one who is actually assembling these PCBs. I'll just show you how much these PCBs cost. And here we have the various signal injector projects. So this one's submitted by Alex. You can see I ordered 5 PCBs. I could have had 10 at the same price, but actually I only need 5. So as part of the sponsorship, it just helps to keep the cost down for PCBWay. Amount, $4.85. And you'll see that's true for all of these small PCBs. Tiny Logic, this is Detlef's version. This is Jeff's version. This is my version. Okay. Tim from Tim's Projects submitted 2. I never said you couldn't, so there we go. So this is Tim's 7555 version and his transistor version, NPN, okay. Thunder Ace's version. And then we have a few other items. So this is the destructive transistor tester, which I built the prototype. These are much larger PCBs. Again, I had 5. You can see the price there, just under $27 for the 5. And this one is the other version of the destructive transistor tester. This is the SMD version, which also includes the front panel. I will show you in a moment. And they were $40 for 5, okay? You can see with shipping, obviously freight costs will depend on where you live. And these were sent on DHL, which is a more expensive courier. You can use the budget couriers for about $5. Again, depending where you live. But PCBWay.com wanted to send me these quickly so I could get on with the review for this month, okay? So that's what we have in there. I'll just show you the items now. And I'll start with the fake transistor tester. This is the destructive tester I built. And here is the prototype of the destructive transistor tester. When I say destructive, it's only destructive to fake transistors. So this tests the maximum current that the transistor can provide. And it can also be used to test the maximum wattage dissipation. If the transistor fails before the stated value in the datasheet, it's fake. As long as you don't push genuine components above the rated values, then that's fine, okay? So this does work, and I ordered 2 PCBs. This is one of them. So this basically replaces the Vero board, which you see down there, okay? It's larger because this actually takes the high current for all the load resistors and the transistors under test directly through the PCB. You can see these big, thick, heavy tracks here, okay, with vias in some of them. So that's why it's larger than that. but it does away with a lot of this external wiring. So when I made this one, all the heavy current is going down through these wires. Okay, so we can populate this and test this, and then if you wish, you can build this sort of tester using this PCB. I will put this up as a shared project so you're all able to do that. Okay, but after testing this, I made another video and decided that obviously this needs some sort of front panel to control it. I lashed this together out of some old bit of copper clad board. Okay, and I had the idea to mount things like the fuse holders onto the front panel, the power connectors and such like, and all the switches. And then instead of having this PCB, put that circuitry on the back of the panel using surface mount devices. Okay, so it does away with this board altogether. And these are what I came up with. So let's take a look at these. They were a little more expensive, but they effectively replace the front panel and that. Okay, these are nice. I ordered quite thick PCB material for these. So you can see on the back here, this is where we put the surface mount components, the voltage regulators, the capacitors, basically what we see on this board, the connectors. Okay, all in SMD. You can see it there. These are the 7809, 7909 SMDs. Okay. The fuses, I then put holes in the front panel to mount the fuses, or the fuse holders. Here's your power connections, your switches. Okay. And you will see there are actually two tracks on this side of the board. I could have effectively done this with some wire links just across the back of here, or using 0 ohm resistors to jump over the other tracks, but I don't think it really detracts from the design of that. It's not particularly noticeable once that's on there. Okay, so that is the version which I prefer, and I think it's the better option all round. Okay, now you'll also notice that this one has 10 switches for 2 amp and 2 switches for 1 amp. Whereas this has 10 switches and they're all 1 amp. So this tester will go up to 10 amps. And many of you will only have a power supply that goes to 10 amps anyway, bench power supply. This version will go to 20 amps. And I have a power supply here, which we can have a look at also. Okay, 0 to 30 volts, 0 to 20 amps. In order to do that, I either needed to change these resistors for 100 watt or to 100 watt and half the resistance, which is 4.5 ohms. You can't easily get that value, to be quite honest. 4.7, yes, but you probably want a bit lower because of the resistance of the wiring to get the 2 amps through. So I decided to order 12 more of these. Okay, and I'm actually going to mount them on top of the other ones. I accept that deteriorates the heat conduction somewhat, but this thing is only used for short periods of time when testing transistors, to be quite honest, and I don't have the space to fit them all across the heatsink. So I'm going to effectively, on 10 of these, put another resistor on top, 9 ohms, that gives me 4.5 on each one, which is 2 amps, and then have 2 more resistors which will fit where this is now because I don't need this, and they'll be 1 amp each. And then you can test, instead of up to 10 amps, up to 22 amps, or the maximum that your power supply can provide, in my case 20. Okay, this is the second time I've tried this approach of making the front panel and PCB integrated. Okay, I did this before with my RF signal generator, you can see it here, and again this has some connections on the back of the panel connecting to the various parts, the rotary encoder, the display, and I also even made a rear panel for it as well. Okay, all out of PCB material. I think this is a really elegant solution to making front panels. I've not seen anybody else do it, and I'm interested to know what you guys think about it down there. Okay, I need to order a few parts for this. I need to order the 7909. I have the 7809. These SMD versions are called 79M09, 78M09, and I need to order the connectors. These don't carry a great deal of current. These literally control the load itself and the transistor under test. So there is not much current flowing through this PCB. And I'll have plugs into these connectors which just wire into the rest of it. Then you can easily remove the front panel if you need to at any time. I may have to order these capacitors as well. So we'll build that one shortly. I think that'll work really well. This is something you're going to see a lot on the channel. It's another way to test not only MOSFETs but also bipolar transistors as well. Okay, for fakes. The first submitted project we'll look at is this one. So this is Tim from Tim's Projects. Here's his YouTube channel. Okay, see. Oh, it looks like he's getting close to 1,000 subscribers. Any of you guys like to give him a little shove in the right direction? That would be nice. I'm already subscribed, so I can't help further. But maybe one or two of you can, or a few. Tim is already submitting these as PCB-based shared projects, so I don't need to do that. Yeah, these are very slender, you can see. Okay. The design uses two NPN transistors. We can see here in the middle of the PCB, Q1, Q2. You can use just about any NPN transistor, to be quite honest. So I'll show you his schematic, which is here. So this is a classic multi-vibrator circuit. Okay, also has a yellow LED in here. He uses SS8050 transistors. And I have S8050. I'm sure that's the same one, to be quite honest. SMD code J3Y. But you could use pretty much any NPN transistor, really, SMD, to build these. These PCBs are really nice, Tim. You deserve some cred for designing this one. This takes the CR245 battery, which are this type, designed for fishing floats, actually. Okay. These are rechargeable, and you can see they fit nicely in here. I know you were using two bits of wire, basically soldered across those holes to make a contact on the battery. I also know, Tim, you said that you later changed the design of the battery holder, so this was your original version. But I think I have everything I need to build this. Maybe not the switch, but I'll have a look. So I think we can build that one now, really, and test it. The battery itself, by the way, you see, lighting the LED in here. So this is what they are originally designed for. I actually tried to dismantle one of these to take the battery holder out of it, basically, or just so we could connect to where the LED is into our project. Unfortunately, this is all kind of sealed and potted in, so I wasn't actually able to do that. But yeah, nice. Well done, Tim. And Tim, the cheeky chap, actually submitted 2 entries. I never said you couldn't, so, well, I can't really argue with that. So here is his second entry. This is the ICM7555 version. So this chip is a surface mount version of the NE555, or commonly known as the 555 timer. This is a ubiquitous chip. I remember using these in the 70s, mid 70s, so they've been around a very long time, and they're still used, they're still available. So let's have a look at the PCBs he designed for this one. These are a similar style design, same sort of battery. This is the 7555 chip, which goes on here. Okay, you can see the rest of the components. The other side of the board isn't populated, apart from the connections to the battery, ground, and the signal injector probe itself. I have 8 of these. Sometimes you find this with PCB where you order 5 You can have 10 anyway at the same price, so they just give me 8. Sometimes they do that. And I'll just compare that with the NPN version. So in actual fact, although the PCB, this one is fractionally longer, this one is wider for the main body, but the actual width is the same, I think, and that's because the constraint is the battery holder. So that is the factor which basically says how small you can make these. Okay, these are small. I didn't measure the other one, so let's do it now. 6.6 centimeters for that one, 6.5 for this one, and the width, well, the widest point across here. Okay, so that is 8 millimeters, or maybe a fraction under, and this one I believe is actually the same. Yeah, 8 millimeters. I can't build this one at the moment. I have all the components apart from the IC. I actually tried to get myself prepared for this, so everything would be here. I ordered the 555s, and I accidentally ordered the standard 8-pin dip versions. Okay, so I have, what, 50 or 100 of these here. They were very cheap, so it wasn't really a problem, apart from the fact I already had quite a few of those anyway. So little mistake on my part, I don't have the chip here ready for that one. I've ordered them now, so that one we'll have to try it a little bit later. Now let's have a look at the design submitted by Thunder Ace. Once again, it's the same basic circuit, and why not? This is proven, it's simple, and it works. Same transistor actually again that Tim used, so we definitely have these here. I'm sure I'll have all the resistant capacitors I need. This is the type of switch. I certainly have these here. And he's using a bent paper clip to hold the battery. Okay. Let's have a look at his PCBs. These are very small. I actually have these in a thicker PCB. This was actually a mistake. So normally the default is 1.6 millimeter thick, which is those ones. A lot of the other projects I ordered either in 1 millimeter or 0.8 millimeter even. Okay. Again, these are very nicely made for such a small PCB. The battery sits across the middle here. Okay, this is a double-sided PCB. These are a little bit narrower than the ones that Tim designs, just under 7 millimeters, and also shorter. It's just over 3.2 millimeters, 3.25. And this actually integrates the switch and the battery on that small PCB. I think this may be the smallest one we have that actually has the battery holder and switch on there, so I'll be very interested to see how well these work. I'm not sure if I have the battery holders here. If not, I'll order what we need. Well done, Thunder Ace, for designing what is possibly the smallest completely integrated PCB we have, but we'll check the others, of course. Anyway, even if it's not the smallest, I like that design, so cred to you, mate. And that brings us on to the version submitted by Alex. And here is Alex's PCB. So this is a through-hole version. It's the only submission of a through-hole one, so obviously this is going to be larger than an SMD version, but as long as it fits into a pen, that satisfies the entry conditions, okay? And obviously this will be easier to build for some of you. This is actually built on my schematic, so this is the original version I built a couple of years ago, and it was actually too large to fit into a pen. So Alex has made this narrower. Okay, we can see it there. And again, built a custom type battery holder. Okay, I think we have everything here we need to build this. Maybe not the correct switch, but we probably have what we need, or at least most of it. And here we see the schematic in the PCB design software. Okay, I have noticed so far at least 3 different PCB design packages that you guys are using. So it's interesting to see you're not all using the same. Let's take a look at the PCBs that Alex designed. And these are of course considerably longer, but only 10 centimeters, so about 3 centimeters longer than the other ones we were seeing, 3 to 4 centimeters. And the width of these, 9 millimeters. So that should fit into, I said, as long as it went into a Sharpie style pen, one of these type of things, then that was fine. I'd be interested to see if this one actually does fit. And although this is a through-hole version, it's actually double-sided, yeah. So this goes to show you can actually produce double-sided through-hole projects. I've never really come across that before. Only SMD being double-sided. So that's interesting. That's a really novel design. Again, I think I have everything to build this, but possibly need to do something regarding the battery holder, and I may not have the correct batteries. Here's another version that Jeff designed. Let's take a look at this one, because I think he used quite a different approach to the others. Okay, and this is Jeff's version. In fact, he used a slightly different method, and this is very much like the one I entered. So this is a dual NPN transistor, BC847S, and a rather novel PCB design. So the switch fits through here. This is the battery. Okay, again, I probably don't have the battery retainers, but it tells us what we need, so I can get some of those. And we actually see how to fit this into a Sharpie pen, exactly like the one I designed. That's an interesting way you've mounted that switch there. Yeah, so it comes through here. Oh, yeah, nice. Okay, so I think I need to get battery holders, and then we can build that one as well. And here they are. So again, they sent me more than the 5. I asked for the 7 of these. That's really interesting design. You're thinking out of the box here. Nice one, Jeff. Yeah. I don't have the transistor. I thought I had these. I can check. Maybe I do. Or I have something else which is equivalent to that. Let's see how big's this. So that's 4.6. And this one is 8 millimeters wide. Okay. I particularly like that. And you can see that PCBWay.com can happily make PCBs of these sort of shapes for you, so they don't just need to be a standard oblong one or even a tapered one like the ones that Tim made. We can do this sort of thing. We have my version, this one, which is the one we see here. So this again is using a little 6-pin dual transistor. I have these dual NPN. If Jeff's version is also NPN, I need to check, then we can use that, I think, on his version as well. Again, though, it may depend on the pin out, so I'll check that one. I noticed some of these have different pin outs. This particular one actually is designed in such a way you could fit the transistor package, the 6-pin, either way round, and it will always connect electrically the same. Okay. And having this particular type of layout meant that we don't have the normal problem of crossing over the capacitor between the base of one transistor and the collector of the other, because you're both on the same side of the chip. It made the layout easier to do, basically using that one, which is why I chose it. Here are the PCBs. I believe this is the smallest of all the submitted versions. Okay. This one really is tiny, as you can see. This is just 1.4 centimeters by, I think it was around 5.2 or 5.4 millimeters. Okay, this is a single-sided board, which should make it easier to assemble, but these are 0402, so these are very small components. This may be easiest to solder using a hot plate. And we're going to find out, because I have everything here I need to build this one. I will just add, by the way, the reason this one is so small is that it doesn't integrate the switch and battery holder, okay? They are external to it. But again, I never specified. I just said it had to have one, okay? So that was my take on it. So with this is the power input, and effectively the switch fits onto here and the battery fits onto the other side of the switch. That is the idea. Let's see how well it works in practice though. And then I have this version, which was submitted by Detlef. So this uses a tiny logic chip. I bought some so I can build this one. And you'll see that this one doesn't contain either a switch or a battery, because these are photodiodes. That's like the opposite to an LED. So light shining on them generates a voltage. So this will work using the light in the room, or at least that is the plan, okay? And because it's activated by light, therefore we don't need an on-off switch. There's no battery to drain. This was very much Detlef thinking out of the box again. This is concept we haven't tried, or he hasn't tried. So this is the side where the photodiodes go, okay? And this is the side where the other components are fitted. I don't have the photodiodes here. If Detlef has some, we can put this one straight together. Otherwise, I'll have to get some photodiodes. The chip I ordered, so that is a Schmidt trigger, and just by using capacitors and resistor, it forms an oscillator, okay? The photodiodes fit on this side of the PCB, so we need a window cut into the pen to allow the light in, and then all the components on the other side. So that is very much Detlef thinking out of the box. This one also is quite small. So we have under 8 millimeters, about 7.5, and this one is 3.4 millimeters long. So there are 7 entries. Now, I will confess there is an 8th entry. I don't just quite recall whose it is, but it was a very unusual design using a little oscillator IC, which only required 2 external components. So it had the lowest component count of all the submitted designs. I ordered the part because it was something quite esoteric I didn't have. And I know at that time I ordered the PCBs, but that one's gone missing. This won't be a problem with PCBWay. This will be a problem with me, because I was answering a number of technical questions about these designs, and it's possible that somewhere down the line that one got missed off. So in other words, it failed the first audit. They're asking me, well, can you confirm this or that? And it's possible that I didn't. In fact, it's likely that I didn't because of everything else going on at the same time. So I will go back to that one. If you are the guy, you know who you are, just post in the comments on this video. I will order your PCBs. I do have the little IC that you're using, and we will see how well that works with so small component count. Thanks guys then for all these entries, plus the one that got missed off, my fault, but I will order those again, so we'll do that one in future. Some of these are very small, especially that one. This has some tiny components as well. So I think we need to look at soldering techniques here. I did say that these needed to be assemblable by hand, okay? And I think this is a very good example of a case where we may try a different soldering technique that we've not used before on this channel. Okay, something new. So coming very soon, we'll have a soldering video. We'll put some of these together. We'll use this technique and we'll see where we can apply this to our repair work as well. Okay, so I'd just like to thank PCBWay.com for sponsoring this video. Thank you so much to all you guys who used your own valuable time to design these. I think we can give them all a round of applause. And thanks everybody else for watching this video, because without you guys watching, this just wouldn't be possible. Okay, so we'll be back soon. Some soldering techniques. I look forward to seeing you all soon again on Learning Electronics Repair. Ciao for now, guys.